there. In some recent lessons, we've been exploring categorical logic. This is a form of deductive logic that is concerned with statements that relate to categories or classes of things. And in our exploration of categorical logic, we've learned some valuable tools for determining whether or not categorical syllogisms are valid or not. So we can construct arguments out of these categorical statements and determine whether or not these arguments are valid or invalid through the use of Venn diagrams, for example. But in all of those lessons, the statements that we've been dealing with are already in something pretty close to a standard categorical form, where I have some quantifier, a subject category, a copula, and then some predicate category, such that we only really have 4 different kinds of categorical statements. A statements like all A's are B's, E statements like no A's are B's, I statements like some A's are B's, and O statements like some A's are not B's. In some of those earlier lessons, I had mentioned that this doesn't really cover all of the things that we might want to say, but it does cover an impressively large range of statements that we could make, particularly if we realize that natural language doesn't necessarily give us categorical statements already in standard categorical form, but that we have to do a little bit of translation, a little bit of interpretation of natural language statements in order to get them into standard categorical form. And that's what this lesson is about. It's about trying to figure out how to translate a natural language statement, the kinds of statements that you're likely to encounter in your everyday life, into standard categorical form so that we can put these formal methods that we've learned through categorical logic to work with statements that aren't already in that standard form of like all A's are B's or no A's are B's or something like that. So what we're going to get in this lesson is a collection of some guidelines or principles, or maybe we might even think of them as rules, but these rules are hardly exhaustive. This isn't going to cover all of the possible translations that you could or even might need to make when trying to use categorical logic with ordinary statements. But hopefully there's a demonstration of some general principles that we can and attitudes that we can bring to this activity of translating natural language into categorical forms. Let's start gently with some examples like this. So we might have to, for example, supply an implied quantifier whenever I'm doing one of these translations. We'll notice in the first example that we have here, the ordinary language statement is roses are red. Well, is that all roses, no roses, some roses? This is a little bit ambiguous. Sometimes people will drop the quantifier when they mean all, and I think that's what's going on here in this statement. When we say roses are red, it seems like we're saying all roses are red. But you'll frequently see people do this when they are trying to say some. Like, for example, if I say, people are saying that Rosenfeld is a terrible professor. We don't mean all people are saying that. We maybe just mean that some people are saying that. The context will usually help you figure out what your quantifier is supposed to be, but this is the sort of thing that you'll have to supply when doing an interpretive translation from ordinary language into categorical statements. And notice in this example too, it's not just that I'm missing a quantifier, I also have my predicate class isn't really a class of things, it's an adjective. So I'm saying roses are red. Well, I need a quantifier, which we've supplied as the all quantifier, the universal affirmation. Roses is a category of thing. It's all the things that are roses. We have my copula, are. And instead of red, which is just an adjective, I need to make this into a class. So I can just say red things. All roses are red things. I could just as easily have said all roses are red flowers, or all roses are, are red looking things. But you get the idea. There are lots of different ways to approach this, but what we're trying to do is clarify what the ordinary language content is in this standard form categorical proposition. And I want to do that as accurately as possible. Similarly, we'll notice here I've got another adjective as my predicate when what I really am looking for is a predicate category. So I've got tigers are carnivorous, again, no quantifier, and I don't really have a category in my predicate, I have an adjective, but that's easily overcome. I supply my quantifier, noting that this seems to be suggesting that it's not just that some tigers are carnivorous, it's that all tigers are carnivorous. And instead of carnivorous, which is an adjective, I need to make this into a category of things, so I'll say carnivores, turning an adjective into a category and supplying a quantifier. Similarly here, we have a few people in the room were visibly upset. Here we have not the quantifier some, but I've seemingly specified this by saying a few. So I just need to translate a few into some. Some people in the room are people who were visibly upset. Notice what's going on here. I have this kind of were visibly upset. I've got a something kind of like my copula verb, my to be verb. It's in the past tense, but again, visibly upset is an adjective. It's not a category of things. So I just need to adjust my language a little bit so that I have my standard form of quantifier, subject category, copula, predicate category. Additionally, I might have to reconstruct a verb in a to be form. We already started to see a little bit of slippage with the copula in that last example with were instead of are, but here's a more clear instance of having a non-standard verb that isn't to be. So some dogs would rather bark than bite. All right, I've got some dogs. I've got a quantifier. I've got a subject category. Would rather bark than bite. What's my copula? What's my predicate category? It's not clear in this natural language statement. I have to translate it. So I might do this by saying some dogs are, and that's always a nice way of starting it. Just start off with my standard copula, are or are not, as the case might be. So this looks like the scenario where I'm talking about are. Some dogs are animals that would rather bark than bite. And here, animals that would rather bark than bite, that's a category of things. That's a class of things. It's not just I'm not sure what I would say the grammatical construction of this is. It would take me back to my sentence diagramming days, but it should be clear that this isn't quite in standard categorical form, and it takes a little bit of tweaking, a little bit of massaging, a little bit of translation and interpretation to get it into that form. Here's another version of the same sort of thing. Some students will become educated. So I have a quantifier and a subject category, and then just some verb. So subject verb. That's a complete sentence, but it's not a standard form categorical proposition. I need to do a little bit of massaging to say some students are people who will become educated. Now I've got quantifier, subject category, copula, and predicate category, the category of all people who will become educated. I might also sometimes need to represent a singular noun or a proper noun as a whole category. This can be a little bit confusing at first, but there are some translational tricks that we can use to make this a little bit more smooth, a little more elegant. So something like, that guy stole your wallet. Well, there's a lot of stuff going on here. I don't have a quantifier. I have that guy, which seems like that's my subject. I have a non-standard verb here, that he stole my wallet. That guy stole my wallet. So what am I trying to say here? I'm trying to say some specific person, and the way that we usually refer to some specific singular thing or some specific singular person in categorical logic is we say all people who are identical to that guy. I'm picking one specific person out. And I'm saying that anybody who is that person is going to be a member of the class of people who stole my wallet. And again, I had to supply that people there. I have to kind of like use my standard copula are and then change stole my wallet into a category of things. So the guy stole my wallet. So all people who are identical to that guy are people who stole my wallet. Same here with Adam skis. This is as simple a sentence as you could possibly get. One noun, one verb, subject, verb, simple sentence, Adam skis. But that's not going to be enough for a standard form categorical proposition. I need to have a quantifier, a subject category, a copula, and a predicate category. So I would do that as all people who are identical to Adam are people who ski. I might also sometimes need to deal with adverbs, specifically some adverbs that deal with space and time. Like, for example, if I have a word like always, always is like clearly talking about all of something. And never seems like it's talking about none of something. And we might, with a little bit of attention, note that what I'm talking about here is at all times and at no times, with always and never. So he always wears a suit to work seems to be communicating that all times that he goes to work are times that he wears a suit. And again, this takes a little bit of massaging, but it's hopefully fairly transparent how it is that I'm getting this content into this structure. I just need a little bit of a trick to figure out how to handle something like always. Similarly, with something like never, I'll note that what I'm talking about is something happening at no times. So none of the times, or at no times that she goes to school are times that she brings her lunch. That's what I mean when I say she never brings her lunch to school. Similarly, with words like wherever, what I'm talking about here is all places. And with a word like whoever, what I'm talking about is all people. So if I say something like, I will go wherever you go, I'm saying all places that you go are places that I'll go. And similarly with this old chestnut, whoever smelt it, dealt it, what I'm saying is all of the people who smelt it are people who dealt it. And you could get a little bit confused here. You might stop and wonder, like, wait a minute, I'll go wherever you go. Is that all places you go are places I'll go? Or is that all places I go are places you go? And similarly with whoever smelt it, dealt it, I might wonder, wait, is this all of the people who dealt it are people who smelt it? Or is it all the people who smelt it are people who dealt it? And it just takes a little bit of stopping and reflecting on, like, wait, well, what does this statement mean? What is it that I'm trying to communicate? And what do these two options mean? Hopefully by now we get a sense that you can't just reverse the subject and predicate categories and still be representing the same content in a categorical statement. It matters whether one category is the subject and the other is the predicate, or the other is the subject and the first one is the predicate. And like switching those around makes a difference. So these are some relatively gentle and simple translations to make, but we're starting to get into some slightly more confusing territory, specifically in identifying that we can get confused about whether or not I want one category to be in the subject place and another to be in the predicate place, or whether they should be switched instead. And the rest of the rules or principles or guidelines that we're going to be talking about in this lesson are really kind of like focusing on those sorts of confusions. For example, sometimes we're dealing with conditional statements. This is a type of statement that hopefully is already at least a little bit familiar to us. We saw this when we were looking at the modus ponens argument form, and we'll see it again when we talk about propositional logic. But we can have statements that have these two parts, this kind of antecedent part and a consequent part, where I say if A, then B, or if P, then Q. For example, if I have a statement like, if something is an A, then that something is also a B, it seems like what I'm communicating here is all A's are B's. And this is a handy sort of a template to keep in mind, that if I can get an ordinary language statement into if-then form, then it's pretty easy to slip from if-then form into categorical all blanks are blanks form. And notice that we have a kind of parallel construction here. If something is an A, then it is a B. My if-then statement has the subject of its corresponding categorical statement in the antecedent, and the predicate of the corresponding categorical statement in its consequent. Let's look at this in some real-life examples, like if it's a mouse, then it's a mammal. What I'm saying is all mice are mammals. And you might stop and kind of wonder, like, wait, hold on, am I getting that backwards? Is it all mice are mammals, or is it all mammals are mice? If something's a mouse, then it's a mammal. No, I'm saying all mice are mammals. In this example, we have jewelry is expensive if it is gold. Notice that we've got a slightly more complicated version of an if-then statement here. It's not clear right off the bat that we've got kind of like the if antecedent, then consequent. The if has been moved to the middle of the sentence here. But usually when I've when I do that, even though it makes this statement just a little bit more complicated, I still have this part is with the if, and then there's an implied then part with the other part of the sentence. So jewelry is expensive if it is gold. What I'm saying is if something is gold, or if jewelry is gold, then that jewelry is expensive. And that's the same as saying all jewelry that's made of gold is expensive jewelry. Similarly, with a statement like this, if something has 4 legs, then it isn't a turkey. Notice, this one's a little bit more complicated because I have a not in my consequent. And it takes a little bit of reflection. It takes a little bit of like stopping and thinking, like, wait, what am I trying to say? To recognize that at least one way of representing this content is to say, no 4-legged creatures are turkeys. This is, again, it's a conditional statement, but it's got a negation in it, and so I've got to figure out a way to represent that negation somewhere in my categorical translation. Here's another one. I will treat people well unless they anger me. This is a conditional statement that's even tougher to recognize because I don't have an if anywhere. I have this word unless. And unless is it functions as an if with a negation. So I could take an approach where I make an E statement out of this, but let's do it a slightly different way. I can represent this in terms of just changing what the category is. Instead of talking about people who do anger me, I'll talk about people who don't anger me, and recognize that when I say I will treat people well unless they anger me, what I'm trying to communicate there is all people who don't anger me are people that I will treat well. And notice again, I can't just arbitrarily switch those categories around. I can't say all people I treat well are people who don't anger me and mean the same thing. That's like a different statement with different content and different meaning. If I translate this statement as all people whom I treat well are people who don't anger me, I will have mistranslated this statement. I won't have represented its content accurately. When I get stuck on these, and it is admittedly difficult, these conditional statements I think are like the next level of difficulty. These are qualitatively more difficult than the other translations that we've seen so far. And when you get stuck, I think especially when you're stuck trying to figure out, wait a minute, is this all A's or B's, or is this all B's or A's? It can be really, really helpful to employ our old friend the Venn diagram to help clarify what it is that we're trying to say, to help take our thinking out of our head where it's easy to lose track of things, where it's easy to kind of forget or kind of be sloppy in our reasoning, and get that thinking out of our head and onto the page where it's a little bit easier to keep track of stuff. So for example, we have like A's and B's here. We have like 2 categories, A and B. And in this version of this Venn diagram, what I'm saying is all A's are B's. But over here, what I'm saying is all B's are A's. And I'll remind us again, with Venn diagrams, we shade to say that nothing lives in this region. So if I shade out all of the part of the A circle that is outside of B, what I'm left with is all of the remaining A's are inside the B circle, or all A's are B's. And I'm doing the opposite over here. I'm shading out all of the B's that are not A's so that all that's left of B is completely within A, or in other words, all B's are A's. So this is my all A's are B's Venn diagram. This is my all B's are A's Venn diagram. And I can use this to try to help me disambiguate between 2 possible options of translating a conditional statement like jewelry is expensive if it's gold. I'll just arbitrarily assign one of my categories to be A and one of them to be B. In this case, I've said my A's are expensive jewelry and my B's are all gold jewelry. And now I can try out different versions of a categorical statement. I can say all expensive jewelry are jewelry made of gold, or perhaps all jewelry made of gold are expensive jewelry. And I can look at the 2 Venn diagrams for these 2 options and try to figure out which one of these actually fits the original statement that I was trying to articulate. So I'm saying jewelry is expensive if it is gold, and A is the expensive jewelry and B is the gold jewelry. Well, which of these represents that better? Am I saying, for example, in this one, well, let's see, jewelry is expensive if it is gold. Well, the B circle is the gold jewelry, but notice I have this whole region is open. That's gold jewelry, but not in the A circle, so not expensive jewelry. I totally have some gold jewelry that is not expensive jewelry, but yet my statement says jewelry is expensive if it's gold. If this jewelry is gold, then it's going to be expensive, but that's not necessarily the case in this Venn diagram. And that might make me think like, well, man, I don't think this Venn diagram actually represents this sentence. Let's try this one instead. This one says, all right, jewelry is expensive if it is gold. So if something is gold jewelry, then it's going to be expensive jewelry. Well, B is my set of all gold jewelry, and A is my set of all expensive jewelry. Here, the only available region of gold jewelry that's left after I've done this shading is the part of the gold jewelry set that's also in the expensive jewelry set. So yeah, here what I've got is if something is gold jewelry, then it's also necessarily in the expensive jewelry category. Yeah, all jewelry made of gold are expensive jewelry. That's the one that fits. This is the version of this statement that accurately translates it into categorical logic. And this one's a little bit of a red herring. This one's like a false lead. Similarly over here, I've got a complicated, like a difficult statement, a conditional statement that uses this word unless, which can very easily throw you. I will treat people well unless they anger me. Let's make A, this set of A, this is the people that I treat well. And remember, unless has a negation, so I'm going to try to represent that negation here in the B circle as people who don't anger me. So A is the people I treat well, and B is the people who don't anger me. So which do I mean here when I say I will treat people well unless they anger me? Do I mean that all the people that I treat well are people who don't anger me? Or alternatively, do I mean all the people who don't anger me are people that I treat well? It might be difficult for me to figure this out in my head, so let's go to the Venn diagrams to help us try to make a little bit of sense of this. I've got a sentence like, I will treat people well unless they anger me. Okay, where A is the people that I treat well, and B represents all of the people who don't anger me. Am I trying to say this, or am I trying to say this? Am I trying to say this, or am I trying to say this? Which one fits better? All right, so when I say that I will treat people well unless they anger me, I'm saying that everybody who doesn't anger me is going to be somebody that I treat well, right? Because I say I will treat people well. I'll treat all the people well unless they anger me. So that means the people that anger me, I'm not going to treat well, but all the people who don't anger me, I will treat well. Let's see, what do we have? B is the people who don't anger me. I have all these people who don't anger me. Some of them are people that I treat well, and some of them are people that I don't treat well. Some of them are in the A circle. Some of them are outside of the A circle. But that's not what I'm trying to say. I'm trying to say that anybody who doesn't anger me is going to be somebody that I will treat well. And I don't have that here. I have some people who aren't angering me, but I'm not treating them well. All of the people that are in the B circle but outside of the A circle. This Venn diagram fits a whole lot better. I will treat people well unless they anger me. B is all of the people who don't anger me. And notice what we've done here is we've shaded out this region, all of the B circle that's outside of the A circle. So all that's left is this section of the B circle that says, like, look, if you're in the B circle, if you're somebody who doesn't anger me, then you are also going to be in the circle of people that I treat well. And that's what I'm trying to say in this sentence. And that's why the second option down here is the accurate translation of this original natural language statement. And this one doesn't really quite work. This is an inaccurate translation. And I can help make sense of this by looking at the Venn diagrams. Just a little bit more complicated than a conditional statement is an exclusive proposition. These are statements where I'm not really using the concept if so much as I'm using the concept only. And as it turns out, the concept only and the concept if are pretty closely related, but one is an inside-out version of the other. So when I say something like only A's are B's, maybe another version of that is none but A's are B's. This is, hopefully we get a sense of like how these mean the same sort of thing. What I'm saying is all B's are A's. And notice the tricky thing that's happened here. When I have an only statement, only A's are B's, the categorical statement that I use to represent that is going to switch the B and A in terms of which comes first and which comes second. This is a little bit confusing, admittedly, but it's the sort of thing that you can track if you stop and carefully consider what it is that's trying to be communicated. So if we have a statement like this one, only cowgirls get the blues, what I seem to be saying here is that all the people who get the blues are people who are cowgirls, or just cowgirls. Maybe I'm saying all the people who are cowgirls, all the cowgirls are people who get the blues. Nope, that's not. That would be all cowgirls get the blues, but notice what I'm saying here is only cowgirls get the blues. Not all of the cowgirls, but all of the people who get the blues are cowgirls, because the only ones that get the blues are the cowgirls. Only cowgirls get the blues. That means all the people who get the blues are cowgirls. Similarly here with a statement like none but the strong will survive, what I'm saying is all of the people that survive, or all survivors, are people who are strong, or are strong people. Not all of the strong people are people who will survive. I'm not saying all of the strong will survive. I'm saying only the strong will survive, or none but the strong will survive. Here we have a statement like I drink only water. That's kind of doing similar work, but notice, kind of like before in our conditional statements, what I've done is I've rearranged things a little bit so that the only isn't at the front of the statement. Now it's in the middle of the statement. But the same principles apply, even though the statement's gotten a little bit more jumbled up and a little bit more complex. I drink only water means all of the things that I drink are water. Not all of the water is something that I drink. That would be like crazy. I'd have to drink up all of the oceans if all of the water was something that I drink. That's not what I'm saying. I'm not saying I drink all the water. I'm saying I drink only water. So all of the things that I drink are water. And last but not least, we have this example like, I will accept nothing except your best efforts. And here again, we've got a none but, nothing except, which is doing similar work to none but, which also functions similarly to only. And again here, instead of at the front of the sentence, I've rearranged things so that now it's in the middle of the sentence, and that makes it a little bit more confusing, but a little bit of careful attention reveals that what I'm saying here is all of the things that I accept are your best efforts, rather than all of your best efforts are things that I accept. And again, I can use Venn diagrams to help clarify this significantly if I'm getting confused by trying to follow this in my head. When I say something like only cowgirls get the blues, I should recognize that, like, well, I've got two obvious possibilities for how to translate this. One maybe is all cowgirls are people who get the blues, and the other one is all people who get the blues are cowgirls. Which one do I mean? Well, I'll set one of the categories as my A and one of them as my B. Let's make cowgirls the A category, and people who get the blues, that's the B category. And the question here is, am I saying all A's are B's, or am I saying all B's are A's? Well, let's try to make sense of this. When I say only cowgirls get the blues, if A is the cowgirls, then this Venn diagram seems to be suggesting that everyone who's a cowgirl is somebody who gets the blues. All the cowgirls get the blues. Is that the same as only the cowgirls get? No, because there are all these people who get the blues that are outside of the cowgirl circle. So no, it's not the case that only cowgirls get the blues in this Venn diagram. So this Venn diagram does not fit this statement. Let's try this one instead. B again is the set of all people who get the blues, and A is the set of all cowgirls. Only cowgirls get the blues. Everybody who gets the blues has to be a cowgirl here. So, like, yeah, is there anybody who gets the blues that isn't a cowgirl? Nope. So, yeah, only cowgirls get the blues, or all people who get the blues are cowgirls. So again, it's this second option that is the accurate translation of my natural language statement. And the first one is, yeah, that was an option at first, but the more I thought about it, I realized, nope, that gets it backwards. That's not what I'm trying to say with a statement like, only cowgirls get the blues. Similarly, with, I will accept nothing but your best efforts, Let's make my A category things I accept and my B category your best efforts. Am I saying all the things that I accept are your best efforts? Or am I saying all of your best efforts are things that I accept when I say I will accept nothing except your best efforts? Let's look at my first Venn diagram. A is things I accept, and B are your best efforts. Am I accepting anything here that is not your best effort? I'm accepting these things, but that's in the best efforts circle, so it seems like what I'm saying here is, yeah, I only accept your best effort. The only thing that I accept are things that are in the best efforts category. I will accept nothing except nothing but the things that are your best efforts. This looks pretty good. Let's try this one instead and see if that one works. I will accept nothing except your best efforts. Well, A is the set of all things that I accept. B is the set of all things that are your best efforts. When I say I will accept nothing except your best efforts, well, look at this. Look at all of this stuff that I'm accepting, all of the stuff that's in the set of things that I will accept that is not in the best efforts set. So I'm accepting plenty of things here that are not your best efforts, and that doesn't match I will accept nothing but or nothing except your best efforts. So in this case, the first option is the accurate translation. The second option is my inaccurate translation. And again, I can make a little bit of extra sense of this. I can kind of stabilize any confusion by externalizing my thought process on the page and trying to reason through this in terms of Venn diagrams for the competing options of translation for my natural language statement. So we've talked a little bit about if-then, or how that if concept functions, and we said that for the most part, whatever's going along with the if seems like it's going to be my subject category. Whatever's going along with a then or even implied then in a conditional statement is going to go with my predicate category. And we've noted that only seems to work backwards from the way that if works. What about if I say the only? This one's actually kind of tricky. You should watch out for the only. If for no other reason, then you might mistakenly think that this is a straightforward only statement. And it works the same way as the last set of statements that we were looking at that just use only in a simple, straightforward way. But the only actually means something different than only. When I say the only A's are B's, I'm not saying only A's are B's. I'm saying only B's are A's. Or in other words, all A's are B's. So the only is a little bit tricky. It's actually a little bit, if I say the only A's are B's, we can see that the categorical translation seems a little bit straightforward. The only just turns into all, and the only A's are B's turns into all A's are B's. That seems pretty straightforward, but what's tricky about it is that you might mistakenly catch that only and think that this is a simple, straightforward only A's are B's statement, where it's not. It's really an only B's are A's type statement. For example, if I have a statement like, the only sound I could hear was the beating of my heart, what I'm trying to say here is all of the sounds that I could hear are the sounds of my beating heart, not all of the sounds of my beating heart were sounds that I could hear. Same here with this statement. The global poor will be the only ones harmed by this policy. What I'm saying here is all of those who are harmed by this policy are the global poor, not all of the global poor will be harmed by this policy. So again, the global poor will be the only ones harmed by this policy. That means all of those harmed by the policy are the global poor. And yet again, if this is a little bit confusing for us, if we find ourselves losing track of this or like not remembering the rule that like the only A's are B's translates into all A's are B's, then I can make sense of this again on a Venn diagram. We'll note that the only is definitely going to be some kind of universal affirmation. I'm going to be able to translate it as a universal affirmation. But the tricky thing here is what's the subject category and what's the predicate category? Is this all A's are B's or is this all B's are A's? So if I start with a statement like the only sound that I could hear was the beating of my heart, and I assign my A circle to the category of all the sounds that I could hear, and the B category to the sounds of my beating heart, I now have this decision to make as to like, okay, am I trying to say it this way or am I trying to say it this way when I say the only sound I could hear was the beating of my heart? In this version, what I've got is all of the sounds that I can hear are the sounds of my beating heart. Is that the only sound that I could hear was the sound of my beating heart? Well, A is the set of all the sounds that I could hear. Is there anything that I hear that isn't in the set of like the sounds of my beating heart? No. So this does seem like the only things that are in the circle of sounds that I can hear are things that are also in the circle of the sounds of my beating heart. So yeah, the only sounds that I can hear are the sounds of my beating heart. This looks like a promising translation here. This option, all the sounds that I hear are the sounds of my beating heart. That seems promising. Let's double check and make sure that the other option, the backwards option, does not work. The only sounds that I could hear were the sounds of my beating heart. Well, A is the set of all of the sounds that I could hear. Oh, I got a typo there. Back up. A is the set of all of the sounds that I could hear. Are the only sounds that I could hear the sounds of my beating heart? No, look at all of this part of the A circle that's outside of the B circle. All of these things that I could hear that are not sounds of my beating heart. Yeah, that's not the only sounds that I could hear are the sounds of my beating heart. That's maybe all the sounds of my beating heart are sounds that I could hear. Yeah, that doesn't work. The yellow version, this first option, that's my accurate translation. This one is the inaccurate backwards version. Similarly here with the global poor will be the only ones harmed by this policy. Let's let my A circle represent the set of the global poor and my B circle represent the set of those harmed by this policy. Which of these options represents the global poor will be the only ones harmed by this policy? Is it this one? Let's see. A is the set of all of the global poor. And the only ones harmed by this policy are the global poor. B is the set of all of those who are harmed by this policy. But look at all of these. Look at all of this part of this B circle that's outside of the A circle. These are all people who are harmed by this policy that are not the global poor. But yet my statement says that the global poor will be the only ones harmed by this policy. This Venn diagram does not represent this statement. Maybe this one does instead. Let's see. The global poor will be the only ones harmed by this policy. A is the global poor. B is all of those harmed by this policy. The only ones that are harmed by this policy in this Venn diagram are things that are also in the global poor category. So yeah, the only ones harmed by this policy are the global poor, or the global poor will be the only ones harmed by this policy. So this version, all those harmed by this policy are the global poor. That's my categorical translation of this natural language statement and not this other backwards version. And just in case all of this wasn't complicated enough for you, let's look at one more option, which is this is easily the most complicated that we'll be looking at. These are what are known as acceptive propositions, and this uses this little conceptual construction of all but. And we haven't really seen that. We saw a kind of like none but or like none except in a previous example, but all but seems to work in a slightly different way. The way that we tend to translate an all but statement, like all but A's are B's, is actually in two categorical propositions. One that says no B's are A's and another one that says all non-A's are B's. And this is really complicated. Maybe even goes beyond some of the stuff that we've learned about Venn diagramming so far. But I think it's still within our ability to kind of like get a sense of, if we understand how Venn diagrams work, maybe we can put them to work in helping to disambiguate how to translate this kind of statement, like a statement like this. All but the tardy students may leave. Well, what am I trying to say when I say all but the tardy students may leave? Well, one of the things that I'm saying is none of the tardy students are students who can leave. When I say all but the tardy students may leave, I'm saying that the tardy students are not allowed to leave. But that's not all that I'm saying. I'm not just saying that none of the tardy students can leave. I'm also saying that all of the non-tardy students are permitted to leave. So it's not just that none of the tardy students can leave, it's also that all of the students who are not tardy can leave. Similarly here in this option, I'm giving full credit to everyone but. That's kind of like all but, right? Everyone is all of the people but. So this is an all but notice it's not at the front of the sentence, it's in the middle of the sentence. This could get confusing. I'm giving full credit to everyone but those who submitted after the deadline. What I'm saying here is, if you submitted after the deadline, you're not getting full credit. And if you did submit before the deadline, which is to say, if you did not submit after the deadline, then you will get full credit. So I'm actually saying two things here. I'm saying no people who submitted after the deadline are people who will receive full credit, and all of those who did not submit after the deadline, if I wanted to put that in other words, I might say all of those who submitted before the deadline, but I want to maintain some consistency here with like talking about people who submit after the deadline. So all of those who did not submit after the deadline are people who will receive full credit, in addition to none of the people who submitted after the deadline are people who will receive full credit. Two sentences, two categorical statements out of the one natural language statement. And I'm not sure exactly how helpful a Venn diagram will be here, except maybe to demonstrate that we're dealing with a very different kind of Venn diagram here because of the way that we're talking about all non-tardy students. So when I say all but the tardy students may leave, let's set my A circle as the tardy students and the B circle as the set of all the students who may leave. When I say all but the tardy students may leave, what I'm saying is none of the students who were tardy are allowed to leave. So that's the E statement in this. No tardy students are students who may leave. And so I'll shade this out. But notice this other statement that I can translate out of all but the tardy students may leave is saying all of those who are non-tardy students are students who may leave. I'm talking about everybody who's outside of the tardy student circle when I say all non-tardy students. That includes these like students who are in the B circle that are outside of the A circle, but it also includes everybody outside of both circles. So when I say all non-tardy students, I'm talking about everything outside of the A circle, including what's in the B circle but outside of the A circle, but also including stuff that's outside of both circles. And when I say all non-tardy students are students who may leave, what I'm doing is I'm shading out everything but the non-tardy students who may leave. I'm leaving only this region of the B circle that's outside of the A circle. That's the only available option to be outside of the A circle. If you are not in the A circle, you have to be in the B circle now that I've shaded out all of this extra region that's outside of both circles. So this is my Venn diagram for an all but statement like this, and that's why I'm getting two statements out of it. Similarly, with this example, I'm giving full credit to everyone but those who submitted after the deadline. A circle is people I'm giving full credit to. B circle is people who submitted after the deadline. What I'm getting out of this is none of the people who submitted after the deadline are people who are going to receive full credit, so I'll shade out that intersecting region. And also, all of the people who did not submit after the deadline, that is to say, everybody who's outside of this B circle, because remember, B is people who submitted after the deadline. So everyone who did not submit after the deadline is everybody outside of the B circle, and I'm saying that all of them are people who will receive full credit. So that means the only option on my Venn diagram for being outside of the B circle has to be in the A circle, so I'll have to shade out all of this region that's outside of both. That last set of examples is pretty complicated. I don't mind saying that's easily the most difficult sort of translation that we'll deal with in this lesson. It's also the last kind of translation that we're dealing with in this lesson. You have a homework assignment that asks you to translate some natural language statements into standard categorical form. As you're approaching that assignment, do keep in mind some of the rules that we've talked about in this lesson, but most importantly, try to keep these broad principles in mind, like try to focus on what the content of the statement is actually trying to communicate and match that against some of the best candidates that you have for a standard categorical form translation and see if they mean the same thing. This requires that you really stop and think about what is it that a statement is trying to convey and disambiguating similar kinds of statements that are nonetheless distinct from ones that actually match the content that's trying to be expressed in the natural language statement in question. And don't forget that Venn diagrams can be an incredibly powerful tool that can aid you in this task. If you find yourself losing track of what a statement might mean by trying to translate it in your head, getting confused about whether or not you're trying to say all A's are B's or instead all B's are A's, know that you can externalize your thought process on the page with a Venn diagram and use that to help you figure out what the content of a statement that you're trying to represent actually is conveying. Best of luck with that assignment, and I'll see you in the next lesson.